Every single day, we're all creating just a storm of digital chaos. But what if I told you that behind all that mess, there's this really elegant system bringing order to everything? Well, today, we're going to pull back that curtain and take a look at the digital library that basically powers our entire world.
I mean, seriously, think about it for a second. Every single time you click something, buy something, all that information has to go somewhere, right? So how on earth does the world organize trillions and trillions of these little pieces of data without losing a single one? That's the huge challenge we're going to unpack today. We're starting from a world of just pure, messy data.
All right, so our journey starts right here. We're going from that jumbled, disorganized pile of data to a system that's, honestly, it's elegant, super efficient, and just beautifully structured.
And the hero of our story? It's the relational database. It's one of those ideas that's so brilliant because it's so simple. The whole concept is just to organize everything into tables, with rows and columns, kind of like a spreadsheet. But here's the key. This structure doesn't just store data. It lets us see the crucial connections, the relationships between all these different bits of information. And that, right there, that's where the real magic happens.
Okay, so the best way to picture this is to think of it like a digital library. A single table, like this customers table we're looking at, is basically one specialized bookshelf. It's only for one type of book, or in this case, one type of information, customer data. Everything's neat, tidy, and exactly where it's supposed to be.
So, following that idea, if the table is our bookshelf, then what's a row? Well, each row is like a single book on that shelf. It's one complete, unique record for one specific customer. And hey, here's a little bit of database lingo for you. You'll often hear this called a tuple. Kind of a weird word, but it's a handy one to have in your back pocket.
And so each column is a specific detail about that book or that record. Think of it like the title or the author or the publication date on the book's cover. We call this an attribute. And using these attributes is absolutely crucial because it makes sure that every single record in our table is structured the exact same way. That's the secret to keeping our data clean and super reliable.
Okay, so we've got our organized library, we've got all our bookshelves lined up, but who runs the place? An army of librarians? Not exactly. What we need is one super smart librarian. And this is where the Relational Database Management System, or RDBMS for short, comes into the picture.
And this right here, this table, really shows you what a huge leap forward in RDBMS is. A simple DBMS, that's what you see on the left. It's kind of like a librarian who can only help one person at a time, using a pretty basic filing system, like folders. But an RDBMS, oh, that's a whole different ballgame. It's tabular, it can handle tons of people working at the same time, and it's built from the ground up to manage the massive interconnected libraries that big companies use today. It's a total game changer.
And honestly, you shouldn't even think of these as just features. They're basically superpowers. An RDBMS doesn't just hold your data. It protects it, it keeps it accurate, that's data integrity. It lets whole teams work on it at the same time. That's multi-user access. And it's built to grow, scalability. We're talking about managing a library the size of a city here, all while keeping everything locked down and secure.
All right, our librarian is pretty smart. But what if we could make them even smarter? Like, what if we could literally give our database a brain? Well, that's the next big step in our story. We're about to move from just storing data to actually teaching it how to think and act all by itself.
Yeah, exactly. I mean, finding a book on a shelf is one thing, that's useful. But what if you need the librarian to automatically run some calculations for you, or enforce some really complex rules, or handle a whole series of tasks in order? For that kind of stuff, just having the information isn't enough. The database itself needs to be able to think.
And the answer to that is something called PL/SQL. It's short for Procedural Language/SQL. And honestly, it's pretty much exactly what it sounds like. It takes the awesome power of SQL for finding data, and then it smashes it together with the logic of a real programming language. We're talking conditions, loops, handling errors, all happening right inside the database. It's like we just handed our librarian a super detailed instruction manual.
And the way you write it is actually super logical. It's not scary at all. First, you declare your tools. You get all your variables and things ready for the job. Then, you begin the main action. This is the doing part, where all your main logic goes. And then, and this is so important, you plan for exceptions. You tell the database exactly what to do if something goes wrong. No surprises.
All right, so we've officially given our database a brain. So what now? Let's put it to work.
This is the fun part, where all that theory becomes reality, and we get to unlock some absolutely incredible power and automation right there inside our digital library.
Okay, first up, let's talk about procedures. A procedure is just a saved set of instructions for a task you do all the time. The key word here is reusability. So instead of typing out the same complex commands over and over and over again, you just write it once, you give it a name, and from then on, you just call that name whenever you need it. Super simple, super powerful.
Let's go back to our library. This is like handing the librarian a single sticky note that just says, "Run end-of-day report." Now, the librarian knows that that simple phrase actually involves like a dozen different steps, but you only have to give the command once. It's crazy efficient, and it pretty much gets rid of human error.
Okay, but now we're getting to the really cool stuff. Let's talk about triggers. A trigger is like a special kind of procedure that you don't even have to ask it to run. It just runs automatically whenever a specific event happens, like when someone adds new data or updates something or deletes something. This is what makes the database proactive, not just reactive.
So think of it like cause and effect. It all starts with the cause, or a catalyst. Some event happens in the database. The classic example is a new employee starts at the company, and their information gets added to the employee table. That's the cause.
And that cause, it has an immediate effect. The trigger just fires. Nobody has to press a button, nobody has to lift a finger. It can automatically figure out the employee's default vacation days, log the new hire in a separate security table, maybe even set a starting salary. I mean, this is automation at its absolute best. It's built right into the fabric of the data itself.
So, there you have it. We've gone all the way from total chaos to perfect order. We went from simple tables to intelligent automated systems. What we've just covered is really the bedrock of how almost all modern data is managed. But you know, it all leads to this one final, really big question. In a world of big data and AI, how are these structured digital libraries going to keep evolving? What's next? That's a story for another day. Thanks so much for tuning in.